Getting ready to start. Okay, thank you all for coming. I'm not sure whether I should be looking to this camera or to the crowd. So today we'll start our series on network complexity. And as the email have described it, it's a series of 4 talks introducing the topic of network and complexity. And we're starting with Professor Jessica Gephart from the American University, but not of Beirut. She's in Washington. Dr. Gephart received her PhD in environmental science from the University of Virginia and completed a postdoctoral fellowship at the National Socio-Environmental Synthesis Center. Her research focuses on the intersection of seafood globalization and environmental change, evaluating how seafood trade drives distant environmental impacts, as well as how environmental shocks disrupt seafood trade. Her work brings together global trade data, local consumption data, environmental impact data to understand opportunities and risks of seafood globalization for sustainable production and food security. So a lot of cool stuff to be talked about and discussed. And as we know, the audience is very varied and we all come from different backgrounds. And that's why we agreed to have a talk that is kind of does away with all the mathematical details, but they're spared for the mathematically minded. If you want to ask the very mathematical question, you can definitely do that. But so it's our pleasure to have you with us, Jessica. And I think I'll leave the floor now for you and we can start.
Excellent. Thank you so much. Can everyone hear me okay?
Yes, we do.
Perfect. All right. Well, thank you so much for joining. And as you just mentioned, I am an assistant professor of environmental science at American University, and my work really focuses on the interaction between globalization and environmental change. For the purposes of this talk, I'm really going to be focused on how environmental change, specifically environmental shocks, as well as other kinds of shocks, can create risks that are propagated through trade networks. Most of my work focuses on seafood trade networks, but I have done some work with other kinds of trade networks as well. And since my work really focuses on this idea of globalization, I like to start off with this image from 1730. It's a map of the world in a relatively pre-globalized state, where it was represented by these distinct quadrants with distinct cultures and environments, and these hemispheres fully divided. This is really a pre-industrialized world where there was fairly limited trade and movement of people. Of course, we know goods and people were moving around, but this was really accelerated with the advent of greater transportation, the decrease in the costs of that transportation, and more recently, the increase in flow of information through phone and internet. And this really defines the idea of globalization that we see, which is the increasing flow of goods, services, and that leads to this greater connectivity. And you can really think about this as being these multi-layered networks that are layering one on top of each other with connections in between each other, creating these increase in flows of many kinds of goods, which are interconnected, but also the movement of services, people, and ideas that connect those. And so when we see this increasing globalization, it really prompts a need for a new understanding about what are the kinds of perhaps novel risks that we see when you're sort of exponentially increasing the number of connections between these different places. And so when we think about globalization, it's helpful to talk about what some of the advantages and disadvantages are before we start jumping straight into the risks, because it's good to keep in mind that part of the reason there's been so much of this increase in connectivity is that it allows access to larger markets and greater capital investment from other locations. It provides consumers with access to a diversity of products that are imported from other areas in the world. And it can allow producers to actually optimize across their supply chains, providing lower cost goods for individuals. And then specifically on the topic of shocks, when you have a localized shock, being connected to these global markets can allow those localities to access goods from other places. And so even from the standpoint of shocks and this what we're going to turn to soon here with this exposure to these external shocks, there is another side to it where that connectivity can buffer against your own local shocks. So those are some of the advantages, but many of us are also aware and think about the many disadvantages that we've seen, including the loss of sector-specific jobs, the fact that reliance on other countries in and of itself can create political risks for individual countries, and that can be politically undesirable. And then there's this idea of being reliant on other countries for your goods and services can create this exposure to external shocks. So if there's some kind of political or environmental event that decreases the export of goods, that can really put a country at risk for its supply of particular foods or other items. And so today I'm going to start off by talking a little bit about why I focus on seafood very, very briefly, and then we'll really jump into the focus of today's talk, looking at some of the impacts of seafood production shocks on trade and food supply, and then talk about a model of which countries and regions tend to be most exposed to these external trade shocks. And then finally, we'll turn our attention some to how we're tracking and understanding some of the ongoing shocks related to the pandemic. And so we'll start off here with some of the background on seafood trade. So when we look at the overall food system, we oftentimes people overlook seafood, but in fact, it is very important for global food security, providing around 17% of animal protein. And it's also a critical source of micronutrients. And that's actually the bigger role that it often plays. And so consequently, it's really important to think about these kinds of environmental shocks and what implications they might have for food and especially for micronutrient security. But then second, seafood is produced in a diversity of ways. So about half of global seafood comes from aquaculture, the other half comes from capture fisheries. Both of those systems have very tight couplings with the environment. So capture fisheries are the last remaining wild food source. And so of course we see population fluctuations and natural hazards that destroy the coastal infrastructure as creating vulnerabilities for those systems. Meanwhile, aquaculture faces many of the same kinds of risks to production that agriculture does, both because it relies on crops for feeds, but also because it's highly dependent on the inputs of freshwater resources. So that could be coming from surface flows like rivers and streams, or from pumping. And so we see these very tight interactions with the environment, and that means that there can be high exposure to those systems of different kinds of environmental shocks. And then the last piece is that seafood is among the most highly traded food commodities as a group, with over a third of the global production being exported and traded internationally. Over the last several decades, there's been, the numbers there got a little fuzzy, but since 1994, there's been a near doubling of trade of seafood products, both in terms of volume and value. There's also been an increasing connectivity in that network. And so that's really of interest here when we're thinking about how shocks might propagate on networks. That change in structure with the average trade partner having an increase in 65% in their number of trade partners. So it's a fairly large increase over that time period just in connectivity. Now we see that nearly every country is involved. Every country and territory is involved with global seafood trade to some degree. So that allows us to really start to think about these questions about connectivity and the implications of shocks across these networks. So now we're going to talk a little bit about what I mean by a shock and what some of the impacts of these past shocks to production have been on trade and food supply. So to start, we need to define what we mean by a shock. And within this work, though my research interest is often on the environmental shocks, I do look at a diversity of kinds of shocks, everything from natural hazards like hurricanes, droughts, and earthquakes, which often destroy the infrastructure required for production and trade. Then there are different environmental stressors that can come to play, like issues with overfishing and stock collapse, or algae blooms or oil spills, as well as habitat loss. And then, of course, there are the many kinds of political and economic shocks related to war, policy changes, and economic crises. So we're really talking about the diversity of different kinds of changes, but in all cases, we're really focused on instances where there is a subtle or a sudden change that happens faster than you can really adapt to that change, right? So we're looking at something that's very sudden and leads to a sudden drop in seafood production. Now, a lot of the past work on shocks and food systems tended to be pretty system specific. So you can define an algae bloom and look at that and the impacts, or a hurricane and look at the impacts. But that is difficult to generalize over the diversity of kinds of shocks. Other systems require long time series. So if you think about floods and what's considered an extreme event for a flood, it requires very long time series to see what sort of falls outside that normal distribution. Or they might be based on just collective reports where everybody essentially just agrees that this event was a shock. But if we want to look across regions and across the diversity of shocks that have occurred, we really need a statistical approach that can avoid some of that geographical or temporal bias. And so the approach that we developed, it adapts a method out of spatial statistics, actually. And we really sort of adapted it in order to deal with a couple issues that are particular for time series. So first, we needed our method to be able to handle differences in scale. So of course, some production, even though these two time series might look relatively similar in terms of having a big kind of hump and then drop, the scales are very different here. And so we need to be able to account for that. There are also time series that differ in terms of their trends, where some might be fairly stable over time, whereas others are increasing. And so it might be increasing then have a drop. And that could look pretty different from being stable and having a drop, right? And then finally, we also need to be able to account for differences in variability in those time series. So some time series have fairly low variability, just with drops at single points, and others are jumping up and down all over the place. Now, this last case is one where the method that we wanted to develop would actually account for that variability and not consider it as having a shock at every up and down, but rather the assumption is really that the system is kind of used to, and that those jumps are baked within the system functioning. And so each one of those drops would not be considered a shock. And that's really what we were focused on within the method that we developed. And so the steps to this shock detection method was to first fit a lowest curve and to calculate the residuals. So we fit a curve to the time series, and then we would calculate the residuals off those curves, off of that curve. And then we would plot each of those residuals at one time step versus the previous time step in order to look at the autocorrelation of those residuals. And so you can see this here is just the time series plot, but here now we're changed and the axes are looking at the residual at one time step versus the next. And really what we're trying to get at here is we want to look at where is there a really big change in the residual from one time step to the next, right? So you can see a fairly big drop here, and we're looking for points like this that are really outliers in that trend, where you'll get a point very far off of the graph. And then the last step here is to identify those extreme points so the extreme values falling off of that regression line. And so we used we used Cook's D as that indicator, and you can see a spike there in that Cook's D here, right, aligning with that same drop in our time series. And so of course we looked over a variety of parameters for sort of the fit of that lowest curve and what to use for our value of Cook's D. And after looking at which were pretty stable in terms of how many shocks they were identifying, we then were able to come up with a set of shocks across countries' seafood production time series. And we then took that set of shocks, and I conducted a literature review and looking both at peer-reviewed literature as well as government reports to identify the plausible cause of that shock. So this is not a causal analysis, but rather taking in a structured way those set of shocks and looking back at what have others said were changes that happened around that time that could be plausible cause for those drops in seafood production. We actually were able to identify a plausible cause for nearly all of the shocks and all of the large shocks that we identified in the data set. So looking across regions here, so this was done at the country level, but we can draw some comparisons across regions. The places that were most shock prone, so the highest number of shocks, were within Central America, the South America, and the Middle East and North Africa. Then but even though those were the ones that had the highest number of shocks per time series, so the distribution of magnitude, so how large that shock was, which was really measured by the residual there, the highest shocks that we saw were within Asia, Europe, followed by Africa. Now, some of these shocks eventually went back to their pre-shock production level. And so we looked at recovery as defined as returning to within 5% of the pre-shock level. But as you can see here, actually, in most regions, only about half of the time series ever actually recovered within the span of time that we had. So the other half never recovered, so they never returned to within 5% of their pre-shock level. Of those that did return, though, they tended to return fairly quickly within 1 or 2 years. So here's the number of years it took to return for that set of shocks that did in fact recover. And those are, in general, pretty skewed toward having values around 1 or 2 years for most regions there. So after we compared these shock events across regions, we were able to then look into the implications of those shocks for both trade and changes in per capita supply. Per capita supply here being a measure of apparent consumption. And so what you would expect to happen would probably be some combination of, if you're having less seafood production, you might expect that there would be an increase in your imports and perhaps a decrease in your exports and supply, where supply is that apparent consumption value. And what we saw looking across all of these different time series was that we did in fact tend to see more cases of increases in imports. The changes in exports are actually fairly split, and there did tend to be a decrease in supply. The exact combination of these changes, though, was very context dependent. And those decreases in supply tended to imply that there would be potential food security or micronutrient security issues. So here is just one of those examples where there was an impact on the consumption or that supply per capita, which is shown in the red line here. This is the time series for Sri Lanka. And if one of the shocks that we detected here was in 2005. If you recall, in December of 2004, there was a major tsunami in Sri Lanka. And that event happened actually on a holiday where there were many of the fishing boats were actually near shore. many of those fishing vessels were severely damaged, and a lot of those fishers were for subsistence and for local consumption. So we do see that drop in production and a drop in the apparent consumption, but relatively limited impact here on either the imports or exports. One other notable thing here with this particular shock is that the fishery was considered to be potentially overfished prior to this, to the tsunami. You'll notice here, though, that very shortly thereafter, there's a rapid rise in production, and it actually catch levels actually exceed what they did before that tsunami. And that's because there were a lot of aid organizations that were engaged in what's called visible aid. So they kind of wanted to be looking like they were out there giving stuff out. And so there were a lot of fishing vessels that were given, and some of the organizations then were accused of essentially creating overcapacity within the fishery, leading to that increase in fishing effort following the tsunami there. And so those changes, those decreases in supply, imply that there could be impacts on food security. And that was in fact documented in the case of Sri Lanka and some of the other cases that we looked at within that study. But in the instances where we see a change in either the imports or the exports, this is where we're really seeing that there could be a case of distant impacts within the trade network. This is where you could have that propagation of a shock across the network. And so that is what we're going to focus on next, is looking at these measures of risk or vulnerability to trade shocks within these trade networks. In order to do this, we took the global bilateral trade data and constructed this global seafood trade network. And I'm going to show an example here. We did it by both region and country. We're going to focus here at the region level, where we impose a reduction in the exports anywhere from 0 to 100% of what their average exports were. And this is represented again as being a sudden short-term decrease. And so the assumption here is that the node or the actor, the country or region, is not able to ramp up their production rapidly. This is actually a fairly reasonable assumption for seafood because they don't have large stocks, so they're not able to release those stocks. We don't generally store large volumes of seafood. And in addition to that, it takes quite a while to ramp up aquaculture production because you have a large infrastructure investment, but also about a year grow out period. And most of the capture fisheries are already operating at their maximum allowed catch. And so this is a fairly reasonable assumption here. We then take that shock and distribute it proportionally to the original flows in one version. We have another version where we incorporate a measure of GDP so that less of the shock goes toward high GDP countries, essentially as a measure of them possibly being able to pay higher prices. Each of those nodes that then got past some of that shock absorbs a fixed percent of the shock locally, and that's expressed as a decrease in the local fish supply. Then they pass the remainder of the shock on if possible, and then that process continues until equilibrium is reached, where the total change across the network equals the total initial shock. So all of the shock has been absorbed somewhere across this network. And so these proportional flows, or the proportions that incorporate the GDP effect, those are represented within the model as a transfer matrix. And there are different ways that you can structure that or impose different behavior on the network. But one really important point here is that in general, we don't actually have a lot of empirical evidence about how this behavior happens. So these models should really be thought of as getting at some of the structural properties that can create risk, but there are a lot of nonlinear behaviors, things like export bans or working within particular trade partners to restructure trade that could really change what you would see from the historical trade flows here. But once we then had this model run, I then was able to look at this risk of exposure within a vulnerability framework, where vulnerability is considered as a combination of exposure, so how much risk you get past, along with sensitivity, so how much does that change in supply really matter within the country, and then finally the adaptive capacity, or the capacity to modify to that exposure, absorb and recover from that particular shock. So looking here at the dimensions of, oh, this figure seems to have gotten messed up in Google Slides here, apologies, but we have along the x-axis the amount of shock that was imposed, and then on the y-axis is, or sorry, the y-axis here is the exposure, so how much of a decrease there was per capita for each 1,000 tons of shock that was imposed on the network. And then the x-axis here is going to be the sensitivity, so which is actually the reliance on seafood for protein. Uh-oh, okay. One moment here. I'm just going to switch which set of slides I'm showing, because that appears to have gotten messed up here, but I still have it on PowerPoint open. And this will look nicer. Sorry about that. All right. So now you can hopefully see the points there showing, these are the regional results, showing where each of these regions falls out in terms of their exposure and sensitivity. The regions that were most exposed within the network tended to be regions within Europe, as well as West and Central Africa. But then when you look at which regions are the most sensitive, the ones that are most reliant on seafood for animal protein, they tended to be, again, within West and Central Africa, as well as Southeast Asia here. And so looking just then, or looking at the combination of these two, can really say that West and Central Africa tend to be the most exposed to these shocks. And some of the features that tend to make countries more exposed than others really has to do with their reliance on these imports and how many different places they could be being sent in imports. So when you have a lot of trade partners and you're really reliant on imports for your total supply, that tended to mean that you're past shocks very often within this model, and that a lot of that those happen in high volumes, and that there was less of the supply that was domestic that you could really decrease from, right? So you'd end up with relatively large exposure to those external shocks. On the flip side, though, looking across the different simulations, there were, of course, situations where individual countries were very reliant on just one partner or just a few partners. And in those cases, they tended to also have very, very high exposure to shocks when the impacted region was the exporter they were reliant on, right? So if maybe it's kind of like putting all of your eggs in one basket, right? If you have just that one trade partner and something bad happens to them, then you're in really big trouble. But if you have lots of trade partners, then there's a higher probability that someone that you trade with will pass you some of the shock. So it's kind of how that's happening there. These findings were relatively robust across the model parameters, and this effect of actually who the shocks were passed to tended to be intensified actually when we included that GDP effect. So especially for those regions within West and Central Africa. Now, bringing in that third dimension there of adaptive capacity, this is some work from Eddie Allison back in 2009, looking at the adaptive capacity of fishing nations. And you can see among the lowest of those adaptive capacities tended to be within some of those same countries and regions that had particularly high vulnerability to these propagated trade shocks. And so that tends to suggest that that this idea of external shocks being passed to them is very, very important to consider when constructing some of these trade policies, and perhaps thinking about modifying trade agreements to provide some buffers and protections against these shutoffs to trade. This particular model was looking at seafood, but we have worked on this with other commodities. So these have built other kinds of these somewhat simple network models where we look at risk based on network structure. So this is a study that I wasn't involved with, but this one here from Philippe Marchand is one looking at grain trade. And some of those results are shown here to the left, looking at where there are the supply decreases and where there are changes in both imports and exports across the network. In that particular model, looking at grains, it showed that the stocks, so how the supply of grains within holding was particularly important, but they also found that the countries that are net importers, developing countries, were also most exposed to these shocks. So similarly to what we found within our model. This suggests that in order to reduce risk to these shocks, there's important to increase the production diversity, to not rely on one exporter far too much, both as an individual nation, but also as a globe. So maintaining some of the diversity in producers is important. And then keeping in place local buffers like those food stocks can be important to buffering those shocks. But as I was saying, there actually is fairly limited empirical evidence to how these shocks are spread on networks. So we have the 2008 grain crisis that provides one example of these kinds of shocks moving across networks. But most of the work that's been done in this space has really been based on some core economic principles and structures of the networks in order to look at how these shocks might create network-wide risk. Consequently, we've been trying to take and track some of the changes in recent and ongoing shocks to understand the responses and some of these shifts in behavior that have been occurring. So to look at this, we've put this within a framework of the food system resilience action cycle. And what this is really describing is it's building off of the definition of food system resilience as the capacity to provide sufficient, appropriate, and accessible food to all in the face of disturbances. And then it thinks about if there's some kind of disruption, we have a first phase where that's just absorbed by the immediate actions of oftentimes households. But then we look at the larger scale reactions and ultimately move toward learning and trying to build robustness to prevent the same kinds of impacts from disruptions. And this has been the framework that we've been using to track some of the responses to the COVID-19 pandemic across the supply chain. So of course, in the past slides, we've really been focusing on countries as the nodes in a network, but you could also think about different actors within a supply chain or supply chains as being the nodes, and each of them faces certain kinds of risks and can in fact propagate these supply chain shortages or pass on some of the economic costs along these supply chains. And that's really something we've been seeing recently here. And looking across this, we can start with some of the impacts that we saw, which was when the pandemic started, we saw an immediate shift in the consumer behavior away from restaurants and toward home consumption. So this was a relatively large shift in the demand. So here's just a plot focus on the US of seafood sales at home and away from home. And you can see in March of 2020, there's just a massive drop, 50% drop from the previous year in the food being consumed away from home. Many of these changes in how consumers were getting their food, though, then sort of moves back and interacts with shifts in those markets themselves. So you can see here, this is looking at Google searches that you had shift toward seafood delivery. So in 2020, that you have this increase in focus on seafood deliveries, as well as home preparation. So that's really shifting some of this market from that restaurant seafood consumption. So prior to the pandemic, about 2/3 of seafood was consumed in restaurants. And then during the pandemic, or the beginning of the pandemic at least, there was a lot more interest in cooking seafood at home or preparing it at home, as well as having it delivered. Then moving back one step further in the supply chain, we know that there were many issues with distribution, and these were impacted by the fact that there were increases in quarantines and increased health measures at ports, closures in ports, as well as shifts in trade patterns from country to country. So some of this was reflected in this is US import and export data, looking at the year-over-year change for frozen and blue versus live here in fresh. The start of the pandemic there, you can see that really big drop in the live, fresh, or chilled category of imports, and as well as exports, eventually with some of that frozen category catching up. That big shift in the live, fresh, and chilled has to do both with challenges to logistics for trading those, as well as that shift in consumer demand toward products that would be more convenient for consuming at home. And so though you would expect that there might be some interaction between those two product categories within those markets. But these trade impacts, they not only stem from those shifts in demand, but also to those restrictions to animal trade. So if you recall, there were concerns at the very beginning of the pandemic that COVID-19 might be actually being transmitted on seafood. And so there were restrictions to and other animals, and so the restrictions to the imports of animal products. There was also restricted air travel, which is really important for high value seafood, which oftentimes is air freighted along with passenger flights. And then those additional health measures in ports really shifted some of these trade patterns around. So we saw, as just a couple examples, that there were canceled exports out of China, and Chinese ships that were coming in had full capacity of frozen products. Many of those were actually rerouted. So at the very beginning, the US absorbed a portion of that product, but then as time went on, the US then itself started to decrease its imports, as we just saw, and those markets had to shift again. Then moving one step back further, we know that in addition to all of these market-based issues, we also had a disruption to labor. This is looking at, here's a map of outbreaks of COVID-19 within US food and meat plants over time. And this became a really big choke point for the supply chain, because they're actually are fairly concentrated. So we have a lot of the product that funnels through a sort of select few number of processing plants for meat and seafood especially. And because of those outbreaks, there were of course then issues with labor shortages, but then some of the economic concerns also led to layoffs throughout the sector. And so this created another sort of simultaneous shock or disruption within the network. And then finally, on the production side, some of those shifts in demand, but also the changes in requirements for vessel observation and for time at sea led to a reduced total number of fishing hours across these vessels. And so that then, of course, shifts and decreases the production available. This is, Global Fishing Watch data looking before and after for 2018 compared to 2020. And we can see here that there was a fairly large degree of variability in what these impacts were. So this is highly averaged in this figure. And it becomes pretty difficult to disentangle what has to do with the policy changes versus the demand changes. And that's one point that's, I'd say, pretty common across this whole project of trying to track these impacts, is that this crisis is still unfolding, and we're seeing how these different actors are responding. But it's not so much a single shock as the way that we often model it, but really it's many shocks across the whole supply chain that have different interactions with each other. And over the time and as that unfolds, we really see that the actors are reacting in different ways that are able to, in some cases, absorb the shock, but in other cases, propagate those disruptions along the supply chain. Just as a few of these adaptations that we've seen for production, there have been reductions in onboard observing, which has led to some concern that there could be issues with sustainable catch with less monitoring on board in the long term. So that could then propagate later issues with overfishing and perhaps stock collapse, where that's been some of the concern. There's been new workplace safety measures that have put in place. Some of that can perhaps stabilize the impacts that we've been seeing in processing, but in other cases, the system's kind of returned back to pre-pandemic levels. But one longer term impact is that across both of those, there's been halting of a lot of investments in new production and processing capacity. Some of that might be ramping back up, but of course, now that we also have this rising inflation and there've been all of these high costs for building materials, that has been slow to start back up again. The shift to new import markets that we saw, some of that really opened the door to perhaps longer term trade relationships. In other cases, it'll be seen whether or not that reverts back. And then on the more market and consumer side, we really saw a lot of companies popping up that focused on direct to consumer sales, things like catch shares. And those can establish these new markets and perhaps create kind of this other more local network of seafood products that may in fact create a little bit more buffering if it's actually maintained. And then across all of these, we've really seen big differences in cases where individuals are designated as essential workers. It's unclear what that will mean for sort of future shocks, whether or not that will sort of force those people to stay at work and reduce some of the shock from that standpoint, but perhaps create greater risk in terms of those later shortages if you have those issues with illness within key nodes along the supply chain, especially processing. And then the relief aid has been in varying amount across countries, across sectors, and it's really rolled out in different ways. And so the longer term implications of that are yet to be seen. So as we take this and move forward toward restoring the restore, learn, and build phases, we really need to learn from these past shocks and try to understand as much as we can from these sort of theoretical models and put that together with where we're really trying to head in order to build a more resilient system. So I'm going to wrap up here with just a few of what we can say across the literature about past shocks and how that might play out in terms of what we're seeing right now with these current shocks. So here's a review that we conducted. Oh, this is actually published. And this is looking at past environmental shocks and in the literature. So this is the number of studies looking at environmental shocks across different stages of the supply chain. And you can see that there's a very heavy bias toward shocks focused exclusively on production, with far fewer looking at the other stages of the supply chain, including aspects of domestic and international trade. So we have a lot less knowledge about what's going on and what risks there might be for those kinds of networks than we do about risks to production itself. We also know that the majority of work has been focused on maize, wheat, and rice, and has really been looking at extreme heat and precipitation. So there are lots of kinds of shocks that we don't understand, and even less that we understand about those later supply chains or what happens when you have shocks to multiple stages. Another thing that we've learned is some work from my colleague Rich Cottrell, who applied that same shock detection method across not just fisheries and aquaculture, but also crops and livestock. And what he found is that shocks are a common feature across food production systems, and that they've actually been increasing in some systems like aquaculture over time. Then, as we looked at earlier, these shocks often do correspond with changes in trade. But one thing that's really critical that we learned from the grain crisis is that it's really important to avoid export bans to not create a trade crisis. And so it's really good that at the beginning of the pandemic, there were agreements around not instituting export bans as we started to see these supply restrictions. And then finally, if we're going to maintain and reduce risk to some of these shocks in the long term, we do need to avoid things like overstimulating production, or putting in place some of these adaptations that might undermine that longer term sustainability. So we need to make sure that proper management is in place for fisheries, but also other measures to make sure there's not over depletion of resources in the short term, which may come at the cost of those long term sustainability. And so really what we can say is that in order to enhance this food system resilience and from that more network or supply chain perspective, it's important to build diversity in the products and producers, and then increase the connectivity across those scales. So looking at the community, company, and country level in order to have that kind of redundancy across scales. And so with that, I'd be happy to answer any questions that you may have. Thank you all for your attention.
Thank you so much, Jessica. I think we've already gotten a question in the chat. Maybe I'll take that in before I take questions from the audience. So we have a question from Ali Ahmad. This question is whether and how these specific are linked to social welfare, and how much such linkages can be leveraged to inform a national or even an international response.
Yeah, thanks. That's a great question. Well, so there are oftentimes it's really hard to disentangle things happening at these global scales all the way down to the more specific social impacts. But we have absolutely seen with other kinds of crises, and we're even seeing a lot of concern over this with the issue of grain trade and Ukraine, that we are seeing higher increases in malnutrition and within areas of Northern Africa and Sub-Saharan Africa. We've seen in the past also with the 2008 grain crisis in parts of Southeast Asia, and that can also create aspects of not only deepen poverty, but also can sort of turn up the temperature on other kinds of social discontent, and so we've seen that, and actually that's been being discussed right now as a factor related to the political crisis in Sri Lanka, is that some of the issues with Ukraine then propagate to price increases for food, and sort of that in combination with the standing issues is being attributed as a potential cause for some of what's happening there. And so it's of course very complex, but when you see these layered issues of already standing inequality in tandem with the increases in prices and shortages in critical goods, we really are able to start to tease out some of those increases in malnutrition and poverty that create that overall crisis. I think that those linkages are actually being discussed to some degree in terms of how do we ensure that despite the war, that there are that aid and exports are able to move through, and that's definitely been a discussion. To what extent it's actually working, I guess, is another question. But then as I mentioned, this issue with we need to put in place measures to prevent export bans and have an agreement not to do that. I think those are being those are along that thinking of how can we have some kind of international agreement to prevent these propagating risks, and take something that is a decrease in exports in one instance, and we don't want it to turn into a full-on global crisis.
Thanks, Jessica. I think I'll start taking questions from the crowd. Yes, please, Sam. Yes.
Hi, thank you for this interesting talk. I love seafood, but my background is in computer science. So I was wondering if you can elaborate a little bit on the technique of the simulation, how you simulate the shock as a flow, and how you determine its effect on a specific region. I think I either missed that or I didn't understand it.
Yeah,
if
sure.
it's possible.
Yeah, sure. Well, so I can let me I do have extra slides to be able to see some of the equations here. I don't know how much you want to actually go through them, but I'll give the overview first here, which is that the model itself is actually inspired by ecological models of looking at resource shocks within trade networks. And the basic idea is that you have a matrix that defines all of your trade flows, and you have each individual in that, and you're able to decrease the exports from a single one of those. And then the key thing for really modeling it is defining what is what's called the transfer matrix, and that is saying how for at each time step, how are you distributing those trade flows, right? And so in this case, the transfer matrix is a combination of the proportions of the original trade flows, along with in some of the simulations a variable that represents the GDP, such that higher GDP countries are passed less of the shocks within that scenario. And so the way that it's being kept track of how exposed they are, how much shock is staying within that country, is essentially taking, you're reducing their exports by a certain fraction and saying that the rest of that shock that was passed to them is retained domestically. And we simulate that across a range of that fraction value. So you can say a lot of that country gets passed on, or only a little bit of that, a lot of that shock gets passed on, or only a little bit of that shock gets passed on. And the rest is sort of just kept track of within, at each time step, you're sort of adding up how much of that shock stayed there. And then after all of the shock is distributed across that network, then, and by that I mean all of the shock is explained somewhere. So however much you decrease the exports initially, it's all been distributed across the whole network. Then we say we stop. And in fact, if there are no, if you don't run up to a point where people can't pass on shock anymore, there's actually a closed form solution to this. So that one's a little bit easier to understand, where we have our end trading partners and then the proportion of shock being passed on. That one we vary and look at its impacts on the overall results. And then we have the exports, and we have that transfer matrix that I was mentioning, which represents those proportions, or the proportions in combination with GDP. And then that is, I guess, represented here, where you have 1 minus Q times your exports being absorbed locally, and the remainder then being transferred across the matrix according to T there. And then because you can kind of think of it as going across these iterations, you then multiply that out again and again, and eventually you wind up with that converging there, and it becomes much simpler to to compute the whole thing. However, if you introduce these alternate behaviors or nonlinearities, then or sort of, and by that I mean like edges where countries can't pass on anymore, then you have to do it as just a numerical simulation. Is that what you're asking? Sorry.
Yes. I think I got some idea. So basically the parameters are specific to the region itself.
Sorry, I can't quite hear you. Might need the microphone again. Or maybe it's my connection, sorry.
No.
Sorry, no.
Battery, I think
Oh, there we go.
this way.
Yes. Hi, can you hear me?
Yes, that's much better.
Okay, good. Yeah, I think I got the idea in general. And it seems that in your simulation, you have specific parameters for each region based on your knowledge of that region. Is that right?
It's based on the historical trade.
Okay, yes,
Yeah.
yes. And is it true that you're somehow assuming some kind of a cycle? Because I think that the geometric series assumes that part of what you transfer comes back at you somehow. Is my understanding correct?
There would only be if you, like, when you have a loop, it can be passed back to you, but we don't have in the seafood model, we didn't have people changing their imports, like increasing their imports and their exports. So it's sending out. We did then add that feature to the crop modeling version. But you would have a cycle if, like, the US exports to Canada, Canada exports to Mexico, Mexico exports to the US, then you would get a cycle.
Okay. Yeah, I think this is enough information. I got the idea, and I think I can always refer back to the paper if I need more. Thank you so much.
Yeah, great. Well, feel free to email me as well, and that goes for anyone.
Thank you.
Let me check. This is working now. Change the batteries also.
Yeah, and I do see another question here.
I wanted to follow up with a question. So
Oh yeah.
if I may, Andre, if I may. So how this percentage of the shock that's getting absorbed, are you linking it to the drop in supply in one way or the other?
Yes. So yes. So we did look at, well, so that is how we get at the percent drop in the supply overall. Yes.
Yeah. Okay.
That's how we.
If I may. Okay. So the countries that you said the shock reaches them very fast were the ones who did not diversify their sources. They're practically connected to few other countries or few other nodes. Where there's something, and you said the countries who had these shocks arriving to them were unfortunate, let's say, to be exposed to the countries who dropped their export one way or the other, right? So their export had dropped, and they were the only source of imports, so they were tremendously hit. Did you look at the, let's say, centrality or any topological measures of these networks to quantify the effect of spread?
Yeah. So I don't think we actually used centrality, but we did look at like in degree and out degree to compare. And we didn't look at centrality here. We did in another paper, but not comparing with the shocks. That would be a good idea. And the Tamea paper actually may have done that, if I recall correctly. I'd have to look back at that. But with just to clarify, so since you can start the shock at lots of different places, you kind of get a different result if you look at risk from one shock versus risk in general, right? And this actually even connects to sort of specific resilience versus general resilience. If you have just a few trade partners, you're less likely to be past a shock if a shock is initiated at random among any countries, right? You're only highly affected if your trade partner either is initiating the shock or gets past a lot of shock themselves, right? So it's kind of like lower probability, but really high impact in that case. If you have lots of import partners that are exporting to you, then you're very likely to be past some shock whenever there's a shock kind of randomly imposed across the country, across the set of countries. And one piece that's important here that I guess we didn't really talk about is this idea of it being your really high net importer. So it means you also don't have many places that you are exporting to, or you're not exporting very much. And that means that you can't reduce your own exports any further. And then all of that shock has to just be accumulated locally. Yeah, and so that's how kind of the in degree, out degree piece, it depends whether you're talking about imposing a shock at random or your high risk to an individual shock. Yeah.
Hi. Thank you for the talk. And I think my question is very much related to the one that you just answered. But basically, when you're trying to simulate that shock, you're starting with a node. And so prior to the simulation, can you, just based on the network topology, kind of infer or the node property at which you're going to start the shock? What is the extent of that shock going to be? And how do you rank the influence of nodes based on that? Is there a certain property, or is it related to external things like the GDP of the country? Or
yeah. So I mean, since these are simulated in the end, the results and the risk are fully determined by the rules that you set up, which in our case does have to do with the network structure. Now, those are based on sort of an existing literature and some basic economic ideas. I think you can have a very good sense of, in these cases, of looking just at your net import and then your number of partners. But yes, that would give you a very good sense of an arbitrary shock, the overall risk. But then that specific shock would depend on where you initiated it, and probably would then relate to the centrality, because as the shock sort of dissipates across the network, more of it's going to sort of funnel through you if you're a more central country, or if you're on the periphery, unless an adjacent node gets hit directly, then it's probably going to dissipate quite a bit before that shock actually reaches you.
Yes, so hi, thank you for your talk. I just have one question related to, can you get back to the slide where you introduced the algorithm that it's it's adapting the scale and the trade and everything related to the network?
Sorry, can you, which one are you?
Yeah, that's where you just introduced the algorithm that it's just like taking into consideration the scale and the variation in the network. It's in the
the time series, like the shock detection part.
Yeah.
Yes.
I just have one question related. So when you talked about the last figure,
this one.
No, one slide can before also. The statistical, yes, here. So this one. So that the algorithm needs to handle differences in scale, threat, and variability. So in the last curve, you said that if the trade of the if it's decreasing over time, so it must not take into consideration that each decrease is just like a shift or a shock, right? So if I have the last curve here, so you said that it must not take into consideration that each decrease is a shock.
Oh, yes. So and that's because if you have sorry.
Yes, so just like my question is like, if I have a trend over like a period of time and I have a sudden change, which is happening gradually instead of just a certain shock, it's not considered at any point just a shock in time?
Correct. So if you have a gradual decrease, that would not be, we would not consider that a shock within our definition. So, and that's in part because since we're really looking at the sort of economic changes when things are in disequilibria. So we're not in any kind of economic equilibrium. We're looking at what are the behaviors during that transition period. And if you look over too long of a time scale, you have sort of adaptation and adjustment happening over that whole period. So you're kind of seeing not those initial kind of crises. It's not unexpected. It's that slower moving change allows people to adjust over time. It doesn't mean there aren't still negative consequences, of course, and you could still have a sudden drop in something else that's driven by a slow moving baseline, right? So if you just think about the standard like alternative stable states, you can create some other kind of shock, some other kind of sudden change by a slow moving baseline. But just for the production itself, we are focused on sudden drops, so nothing gradual. And the point about variability is actually more about just if you have a system that's already really variable, then each drop is kind of, it's not unanticipated necessarily. It's within the way that the system has been functioning. Again, it doesn't mean that it doesn't have bad consequences, but we sort of assume that that's part of how the system works. Yeah.
Yeah, I mean, Garo's question is also kind of ties in with Rena's on the gradual decrease over decades or years. So does your statistical model take this into account as disruption? I think it's kind of very much tying in with Rena's question.
So how you'd have it handled if you had a gradual change would be the same as a gradual increase. All of that, you're essentially detrending things. You are detrending things when you fit the lowest curve and then calculate the residuals. So so a gradual decrease will not be considered a shock. It would only be if there's a big drop at some point. Otherwise, yeah, the whole time series is detrended.
Yeah, I have a few questions. First, I want to thank you for a very stimulating lecture, and we hope to have you here on campus with us for a more extended discussion and interactions. On this part of your presentation, you ended up with some recommendations which seemed like fairly common sense recommendation. Diversify production, diversify spectrum of suppliers, and have a buffer. Now it's somewhat disappointing to go through this detailed amount of work to come back to the age-old prescriptions. Did we learn anything more fundamental, generic, and perhaps more appropriate to the state of globalization that we are living through, which I'm sure is presenting us with challenges that go beyond the scales of local response to shocks such as the ones you described in the first part? That's a first question, but I will follow it up with related questions, if I may.
Yeah, sure. So I don't think for when trying to draw conclusions about shocks in general, so any kind of shock across any kind of country, I don't think that we've come up with any new rules quite yet. They do tend to kind of agree and mirror the sort of general resilience properties. I think we learned quite a bit though about looking at individual shocks and individual case studies. And part of that is how much context matters in these different individual cases. And so one thing we've been trying to do, well, two things we've been trying to do. One is build up a database of these different shock cases to try to understand a little bit more about are there generalizable things that can come out of certain types of shocks, whether they be political or environmental. If you're comparing, say, something like a tsunami or hurricane versus an earthquake or harmful algal bloom, can we start to say something different and more generalizable by shock type? So that's one thing. The second is can we come up with something more generalizable about when you have multiple simultaneous shocks, either across a single supply chain or across different locations. And so I think those are two really big areas where we might be able to say something more generalizable, but not necessarily generalizable to every type of shock for every type of country. So we are trying to develop that. And I think we already do have quite a few insights just looking at these individual shock cases, which I'm happy to talk about some of those examples later. But the second thing is that we're working to try to actually trace these shocks across the network. So part of how these simplified models were built, it's not too surprising that they wind up finding a lot of the same kinds of patterns that we see if we think about networks in general. And that's because it builds up from all of that interrelated theory, right? But we're really working to develop methods that can empirically follow these shocks across networks. So I've been trying to adapt a method called synthetic control that's been applied in political science to the network context in order to actually attribute changes in these network flows to individual shocks. So I've been working on a case looking at a harmful algal bloom that impacted salmon production in Chile to actually try to better empirically trace that shock through the network and see if there actually is behavior that differs from the kinds of behaviors we might expect just based on things like GDP and network structure of trade networks. And so that's where I'm more hopeful that we might be able to find conclusions that would depart from those more generalizable ideas. Yeah.
Can I ask another question? So I come to your talk with a physics background, and so our concern will be principally with timescales, and at least to start out with timescales over which shocks are felt, timescales over which shocks are propagated or in some sense absorbed, as you described. Do you have anything of a universal character on this front or on this side of the story? And a related question, do you have any historical archival studies that allow us to make statements about the change of the timescale over which these shocks are being felt as a function of the accelerated aggressive globalization that we are going to? Can we make any statements of this nature about the state of the network we are living in right now, say in comparison to something that happened about, I don't know, 50 years ago or 100 years ago?
That's a great question. I don't have empirical evidence for it, and the trade data really only goes back to the 90s with any confidence. So it would be harder to go back much further than that, though. There may be ways more with working with, say, a historian or an archivalist to look at some of those impacts. It wouldn't be an apples to apples comparison. The issue though of timescale, I think, is it really important. So what we're looking at before was the data that is at an annual scale, but there are really interesting things that happen subannually. There've only been bilateral trade data available at the monthly scale for globally since about 2014. And so this is that case I've been working on that I mentioned with Chile. This is the time series of who was of exports from Chile to each of its import partners. The shock magnitude of this is about 1,000 kilograms, so it's about a 25% decrease from before this algal bloom. And in this case, that shock actually was divided about equally. So how that decrease was felt was about equally between the Philippines, which is a major processor, the US and Canada. Though in terms of like how quickly do things kind of return back, one way that we are trying to understand that is through prices and the global prices. So this is the global salmon index here, and you can see that following that harmful algal bloom in the spring there, you can see an increase in prices, which peaks actually in the fall there, so a few months later, and that's really when you start to see Norway is able to release more of its supply, and the production in Chile improves, and their exports there ramp back up, as you can see, and the price comes back down to about where it was before that event. You start to see the price climb again, and that's actually due to a separate reason, which is that there was a sea lice outbreak, or well, we think it's due to a separate reason, which is there was a sea lice outbreak there in Norway. So I think actually a lot of this, I think the speed for a lot of these shocks actually is quite rapid and is probably happening at a subannual scale, except for maybe with the really, really big shocks. And with those, there's a lot more unpredictable behavior though, because those tend to be affecting multiple people, multiple stages of the supply chain. Yeah. Was that what you were getting at, Fadi?
Fadi had a question. Fadi, you had raised your hand. I don't know if Jessica had answered your question in one way or the other. No. Okay, Garo, you can unmute yourself if you want.
Yes, thank you for your presentation. So I have a question. What caught my attention was the case of the canceled Chinese exports during the COVID-19 pandemic. So in such a case, would the country not count as a node in the network since it's not trading, or would its influence simply decrease?
So they were still trading, but they decreased their imports substantially, which is actually fairly different than we didn't explicitly model a cut off of imports case, though you certainly could. And so yeah, we didn't quite look at that, but it is actually interesting. They were more cutting off imports. The case that we are looking at that a bit is we're right now looking at trade before and after the annexation of Crimea in 2014, because we're interested in some of the bans that were put in place. So Russia stopped importing from some of they basically had counter sanctions of some of the places that were placing sanctions on them for the annexation of Crimea. And we're looking at the sort of rerouting through third parties. So we're trying to understand essentially where the decreases that we saw with some trade partners, was it, are they sort of like total decreases, or did they just flow through other routes across the network? So yes, we haven't quite looked at that, but I think that I guess more back to your question of with China, they represent, I guess, a decrease, and then some of that trade flow was rerouted in their case.
Oh, I see. And I also have another question, if you don't mind. It's kind of relevant to what I had asked in the chat, and a variation of which was asked by the audience. So it has to do with the time frame for a shock. So do you find that by the time that you have detected a shock and found its implications, that the response is quick enough for the people involved, the countries or the organizations involved, to take countermeasures?
It is not, because there's generally like a 2 or 3 year lag in quality trade data reporting. And similarly, it's like a year or two with the global statistics, a year or two with the production data. And so when we're looking at real-time events, we've been looking to other data sources. So actually with some of the COVID impact tracking, part of the reason we did the trade piece with just US data is because the US updates their data every few months. And so we had much earlier access to that. Some of the other sources that we were looking at about other supply chain impacts were drawn from like Google searches and others, and news reporting sources we drew from to be able to understand and track those impacts. We have been trying to develop a method using a big global news database to try to detect changes or spikes in reporting around lots and lots of different terms about shocks and see if those correspond to networks. So we've been trying to see if we can get an early warning signal out of news and these other sources that have much more frequent reporting. But it's not quite there yet. So there's more work to do on that one. We're not getting a very clear signal with that. Yeah, thanks.
Okay, thank you very much.
Thank you, Jessica. I think we can still take one more question from Fadi if the audience here is done with questions. Fadi, please.
Thank you, Sarah. And thank you, Jessica, for the nice talk. My question is the more curiosity question about the data and whether it can support analysis on a micro level. So instead of just looking at the countries, look at the markets, at the unions, at the labor that is supporting this seafood market, if you may. I mean, if you look at smaller markets, at intra-country relations, relations between markets, between even restaurants, supply chain, big companies that are across continents or across countries, does the data support such kind of analysis or not really?
Not that I'm aware of. So company data is really hard to come by because it's generally proprietary. There are other people, other initiatives that I'm not involved with that are trying to get such company level data, but oftentimes, since many of these big companies are vertically integrated, you're essentially asking them for internal financial information, and they're not. My understanding is that it's really hard to get access to that. From the company side. There is internal trade data for some countries. So for the US, we do have internal trade data at the county level. So it's pretty highly resolved. And we've talked some about trying to work with some of that data, but you get finer spatial resolution, but it's only every 5 years, and it's much more aggregated in terms of the products. So you get like all meat and fish in one product. And so they're pretty, I think we'll get there maybe eventually. And I'd be really curious to hear from others at some point. I love creative solutions to try to get the data, and there's always more and more data. So I think there'll always be opportunities to try to be creative about uses. But my understanding is right now, there are some limitations to that kind of finer scale work.
Yeah, I mean, the effect on the labor and the families living from the market is also something worth studying, not only whether we have supply or not, like what happens with the people working in this domain if there is a shock, right?
Yeah, so we do have some of that actually from a collaborator in Madagascar following a tsunami. We did surveys after that to understand both the fisher side and the household responses. And some of the aid organizations have standardized surveys for surveying that. And so I think there would definitely be opportunities for looking at those impacts and adaptations. Those do come out, and development organizations do in fact do use those afterward. Many times we don't have the pre-information for those locations because you only know after the fact. The one in Madagascar is interesting because it's a collaborator who's been working there for 20 years, and he's a really close collaborator of mine. So he has a lot of data about the situation before this hurricane or cyclone. Yeah.
Thank you. I appreciate it.
Yeah, thank you so much.
Thank you so much, Jessica. I think we have no more questions from the audience. I guess we just have to thank you for being with us virtually. Hopefully we'll have you come over to Beirut, to the American University of Beirut in this case, and maybe engage with the community at a closer distance. And because as it seems, the audience was very much interactive and they have a lot of questions, and we kept you for half an hour past the schedule. So we're very thankful for that. So just let's thank Professor Gephart.
Yeah, thank you all, and I hope to see you in person at some point.
Yeah.
So, all right, take care.
Thank you.